Introduction to structural analysis. So before we go into structural analysis, we have to define first what is a structure. So a structure refers to a system of connected parts used to support a load. So it is a system. Now say for example, our houses. So ang houses natin, this is a system of connected parts. So ano yung mga connected parts na yon? You have your slab, your columns, and your beams. And most importantly, it should be safely to support a load. So, ano ba yung mga load natin sa bahay? Say, for example, tayo yung magiging load sa mga bahay-bahay natin. So, kaya ba tayong buhatin nung house natin? Definitely, it should. So, important examples related to civil engineering includes buildings, bridges, and towers. Hindi lang naman yan. So, we have a lot more structures, pero ito kasi yung pinaka-common. So, you have buildings, say, houses, our malls, ayan, and a lot more. You have your bridges, and you have your towers, mga cellphone towers, like that, and a lot more. So, when you are designing a structure, to serve a specified function for public use, the engineer must account for its safety. Siyempre, kailangan yung structure natin, it could carry load safely. Then, aesthetics. We're not really that into aesthetics because this is actually the job of architects already. But we have to consider also. Kasi in my experience, pag ako magde-design, syempre, rectangle lang yan or just square. Pag nag-analysis kasi kayo ng structures na it is regular, it is simple, therefore, our analysis there is also simple. Now, compared pag irregular yung shape ng structure nyo, definitely, you have a more complex analysis compared niya sa regular na structures. Then lastly is serviceability. So what do you mean by saying serviceability? It serves its purpose. Now, number one here is yung houses natin. So what is the purpose of our house? It provides shelter. Now, you have to ask yourself, does the house provide shelter? Then if it's yes, therefore, while taking into consideration these three, also have to consider economic value of the structure. Siyempre, pag nagde-design tayo, pwede bang mas maliit yung section natin? Say, yung concrete natin, pwede ba nating paliitin? There are ways to do that one. Then, lastly is the environmental constraint. This design process is both creative and technical and requires a fundamental knowledge of material properties and the laws of mechanics that govern material response. Kaya nga, before you go through structural analysis, you already have gone through your construction materials testing for you to know the properties of your materials. So, ano ba nangyayari sa mga materials natin pag linagyan nyo ng loads like that? And also the laws of mechanics or yung statics nyo. Once a preliminary design of a structure is proposed, the structure must then be analyzed to ensure that it has its required stiffness and strength. So, ganun po yung process ng designing nyo, right? You have already a preliminary design. Then, afterwards, you have to check again if it is strong enough to carry the loads na mga binigay natin sa structure. So, yan yung structural analysis. We have your classification of structure. So, we have number one is tie rods. So, ano ba yung mga tie rods natin? So, most of the time, our tie rods are just circular bars. Pwede din siyang magiging angle bars and a lot more. So, this one is our tie rod. So, ito po yung tie rod na example. This one. Ayan. So, most of the time, our tie rods are in tensive pores. Tensive pores. Ayan. And also, ginagamit siya for bracing. Ayan. And most of the time, it is slender ang tie rod. Then, next one is you have your beams. So, for in reality, we have your beams here. Most commonly, pag nag-statics kayo, madalas na beams na ginagamit nyo is the simply supported beam, which is you have your hinge, then you have your roller. So, this is a simply supported beam. You also have cantilever. Ayan. Yan, meron din kayong prop beam. So, ang prop beam, you have fixed there and you have roller here. So, yan yung mga beams natin. Then, we have your columns. So, ang column naman is this one. Ayan. Then, you have your trusses. Now, yung trusses natin, most of the time, sa bridges siya. Or, we can also use trusses in the roof, which is here. Ito, mga roof truss. There you go. Then, you also have your cables and arcs. Yung cables and arcs, common siya sa mga bridges, which is here. Ayan. You have your cables here. Ayan, mga cable yan. Also there, that's cables. Then we have your arcs. So, ito naman yung arcs natin. Then we have your frame. So, here, we have a building frame here already. So, later on, you will know the differences of this classification of structures. Then, you also have your loads on structures. So, most of the time, yung loads of structure natin is galing sa NSCP. When we are designing, we actually get it from NSCP. Now, pag hindi siya available sa NSCP, so, parang mini-measure na lang natin ng sarili natin or sa kung saan yung pinagkuhanan yung material. Most of the time, binibigay naman nila yung weight ng structure or nung material. So our code, which is the National Structural Code of the Philippines 2015, we have actually a lot of edition of NSCP. We also have the 2001. We also have yung 2010. Ayan. So, yung 2010, ito yung naging 2015 lang siya. Inedit siya because of the Yolanda na typhoon, because of Yolanda typhoon. Kaya tayo nagkaroon ng 2015. Because in 2010, I think our wind load here is just 200 kph. Now, pagdating naman ng Yolanda, I think umabot siya ng mga 300 kph. I'm not sure. Ayan. So, parang nung nagkaroon nga ng Yolanda, ayan, nag-meeting-meeting na ang mga taga-ASEP to revise the NSCP 2010. So we have the NSCP 2015. So the design codes provide detailed technical standards and are used to establish the requirements for the actual structural design. So take note, this one is just technical standards. It should be realized, however, that the codes provide only a general guide for design. The ultimate responsibility for the design lies with the structural engineer. So again, you have to take note that our NSCP, it is just a general guide. But it is, yung NSCP natin is based on research, also based din yan, actually kinopya lang din natin yung NSCP natin from other countries, ayan. So I think the standards naman given by our NSCP is also safe. So again, but even though we have your NSCP, the ultimate responsibility again is with or lies with the structural engineer. So we have your loads on structure. Number one here is the gravity loads. So ano ba ang gravity loads? Ang gravity loads, this is just by the word itself, loads based or due to gravity. So actually, ang dead load, it is under gravity load, and live load also under gravity loads. So, ang dead load, most of the time, we call it the self-weight. Then, yung mga live load, this one naman is yung mga moving loads. Not only moving loads tayo, mga furnitures, ayan, live loads po yung mga yan. Then, you have your snow and rain loads. But here in the Philippines, we don't really actually have snow. So, most of the time, rain loads lang. Then, we have your hydrostatic and soil pressure. The soil pressure here is mostly for foundations. Pwede din sa mga retaining walls like that. And also hydrostatic. So, ang hydrostatic naman is also for retaining walls. Also dams. Ayan, hydrostatic. Then we have your impact loads, you have your wind load, and you have your earthquake loads. So, these two, yung wind load and earthquake load, mostly mapag-aaralan nyo to sa earthquake engineering nyo. So this is the loads on structure. So our first topic here would be the tributary area. So what is a tributary area? If you say tributary area, you have a column here. So ano ba yung kayang buhatin ng column na to? Or ano yung area na binubuhat niya? So here we have your column B3. So this is your tributary area. So, ibig sabihin, tong column na to, ito yung binubuhat niya. Okay? So, here, yung column A4, again, ito yung binubuhat ng column na to. And also this one, if you have your column here, ito naman yung binubuhat ng column C4. Now, how about for beams? So, pag beams naman, you have this beam. So, ang binubuhat ng beam na to is this one. So, yung area na ito na binubuhat ng beam, that is what we call your tributary area. Also here, if you have your beam here, ito naman yung kayang buhatin ng beam na ito. Okay? So, say, pwede din to, itong beam din na ito. So, kunin mo lang yung kalahati at yung kalahati here. So, say this one is 4 meters. This one is also 4 meters. Kunin mo yung kalahati dito. So, this would be 2 meters. Then, kalahati din na to. So, this is also 2 meters. So, this would be the tributary area of this particular beam. Also sa column. So, kalahati and kalahati din. So, half-half. So, this one is 4 meters. This one is also 4 meters. Say this one is 3 meters. And this one is also 3 meters. So, you get here the half of 4. So, that would be 2 meters. Half din ito, 2 meters. Half, 1.5. 1.5. So, therefore, this beam, yung column B3, your tributary area would be 4 by 3. So, ayan. So, that is your tributary area. Now, say for example, kunin natin yung load here at column B3. Considering only the concrete slab. So, ang concrete slab, you have your unit weight of concrete. That one is 24 kilonewton per meter cube. This is the unit weight of your concrete. You can use 23.6 at. So, ang load natin, you have your column. Remember from your construction materials, di ba meron tayo yung cylindrical na concrete, then we have yung beam, yung flexural. Now, take note, if you are considering a column, most of the time, ang load natin dito are just concentrated load or compressive lang. So, therefore, if you have a column, you only have here a concentrated load like in terms of kilonewton. So, ito lang yung magiging load natin sa column. How about in beams? Now, again, from your construction materials testing, meron tayong mga rectangular beams, di ba, na tinetest. Ang ginagawa dito is a flexural test, which is a concentrated load here. Pero kasi, mahirap kasing sabihin ng concentrated load sa beams natin para ma-distribute natin yung analysis sa beams. Therefore, ang ginagawa sa beams is our load here would be a uniformly distributed load. So, say here, ayan. So, ang magiging unit natin dito would be kilonewton per meter. So, if we are considering columns, dapat ang load natin dito magiging kilonewton. Pag beams naman, should be kilonewton per meter. So, gagamitin natin to for us to know kung ilan ba kayang buhatin or ilan ba ang binubuhat ng column na yon. So, say let's solve for the load at column B3. So, we will have here dapat kilonewton. So, we have a unit weight of concrete is equal to 24 kilonewton per meter cube. So, paano natin ito gagawin kilonewton? So, kailangan natin siya i-multiply by meter cube. So, paano natin kukunin yan? So, we have to multiply it to meter cube, which is the volume, di ba? So, therefore, our dead load or yung load natin here in column B3, kunin lang natin yung tributary area. So, we have 2 meters here, 2 meters, 1.5, then 1.5. Then, what else? Yung thickness nung slab natin. Say, ang thickness of slab is equal to, sabihin na natin 150 millimeter. So, you just have to multiply. So, we have 24 kilonewton per meter cube. So, let's multiply it to the tributary area. So, you have 4 meters times the 3 meters times the thickness of slab. So, thickness of slab, 0.15 meters. So, this would be 24 times 4 times 3 times 0.15. 43.2 kilonewton. So, that would be our load here. So, ang column B3, so say this one is your column B3, ang load lang natin dito would be 43.2 kilonewton. And that's it. Now, how about naman if you have beams? Say, let's use this one. This beam, CD22. So, same. You have your unit weight of concrete is equal to 24 kilonewton per meter cube. Now, here, sabi niya kilonewton per meter. Now, dito naman, paano natin siya gagawin ng kilonewton per meter cube? You have to multiply here an area. So, ano ba ang area na gagamitin natin? So, we have here your beam. Yan. So, ito yung beam natin. We have CD22. This one is 4 meters na beam. Then, you have here your uniformly distributed load. So, ano to? So, we have to solve for that one. Now, take note, yung unit weight natin is naka 3-dimensional siya. So, here, say this one is the, 3D. Yeah. So, this one is 4 meters, then this one is 3 meters. So, nandito yung beam nyo, sabihin nyo nandyan. Now, yung load natin here is 24 kilonewton per meter cube is 3-dimensional load. So, therefore, it is like that. Now, i-convert mo itong load na to in just a 2-dimensional load. So, dapat nandito lang yung load natin. So, here. Yan, magiging ganyan yung load natin. Now, ano ang i-multiply natin for us to get this particular load? So, hindi naman pwede na 4 times 3, di ba? Kasi pag 4 times 3, eto na yon. So, ang ginamit mo kasi dito, 4 meters. Now, what will you multiply here para ma-convert siya dito. So, therefore, you have to just multiply it here para maging uniformly distributed. So, you have 24 kilonewton per meter cube. So, you will just multiply it to 3 meters. So, isa pang meter para maging meter, para ma-cancel yung dalawang meter kasi tatlo yung meter dito. So, ano pa yung i-multiply natin? Hindi yung 4. Kasi yung 4 meters, this is the length of the beam already. So, ibig sabihin, nagamit na yung 4. Ano pang hindi pa natin nagamit? Yung thickness of our concrete. So, ano ang thickness of our concrete? It is 0.15. So, therefore, our load here would be, so we have 24 times 3 times 0.15. There we go. So, this would be 10.8. So, our load is 10.8 kilonewton per meter. So, sa beam natin, this would be 10.8 kilonewton per meter. Okay? So, we also have what we call your one-way system and two-way system. So, para saan ba ito? Now, your one-way system and your two-way system dictate the shape of your load sa beams. Now, in your beams here, ang ginawa kasi natin, automatic, it is a uniformly distributed. But in reality, we have one-way and two-way system. So if you say one-way system, our load here would be simply a uniform load. So pag sinabi mo kasing one-way system, this is a short or small area of a structure. So one-way system, so you have your equation, S divided by L is less than 0.5. So what is S and L here? So if you say S, this one is the short span, or you can just say the smaller dimension. Smaller dimension. And your L here is the long span or the larger dimension. Yan. So we have here, say this one is 4 meters, then you have 2 meters here. Oh, kulitan natin ha, this should be 5 meters. So we have this slab. So this slab, kasi diba remember, if you are getting this beam CD, so you have here half and half. So ang kino-consider mo is this one, kasi kukunin mo nga yung shape nung load natin. So we have here yung short span or our smaller dimension would be 2 meters. So 2 meters divided by our long span or larger dimension, which is 5 meters. Then this one is 0.4. So we don't actually have a unit here kasi mag-cancel yung meter. Then you compare it to 0.5. So yung 0.5 natin is larger, so 0.4 is less than 0.5. So therefore, our load for beam CD is a one-way system. Yes. Now, how about naman here, two-way system? So same, your S here is your short span or your smaller dimension. Your L here is your long span or your larger dimension. So say, for example, this one, you have 10 feet, then 10 feet. So you have 10 feet, 10, this one is equal to 1. So 1 is greater than 0.5. So therefore, it is a two-way system. Now, say pag this one is the same as your side here, so equal yung here and here, ang magiging load natin dito is a triangular load. So, also take note, 45 degrees, 45 degrees. So, ganito yung magiging load natin for this beam. Say, yung beam AB natin. So, here, you also have to take note that yung computation natin here is the same as what we did a while ago. So, ganito din siya. So, say for example, yung beam CD natin, let's see ha, this one is 3 meters divided by 4 meters. So, this would be 0.75. So, this one is smaller than 0.5. So, this is greater than. So, therefore, it is a two-way system. So, therefore, ang load natin dito, supposedly, is not a uniform load. So, dapat magiging two-way system siya. You also have to see. So, ang long span natin is always a trapezoidal load. Pag short span naman, it is a triangular load. Now, pag equal sila, definitely, magiging lang siya, triangles. So, therefore, ganyan yung magiging itsura. Pag you have the same size here, 10 feet, 10 feet. Pero pag ganito, you have 15 feet here. Whichever is larger, yung load natin doon magiging trapezoidal. And the shorter span would have a triangular shape. So, dito, your beam here actually would be a triangular load. So, dapat ganyan siya. So, again, the 10.8 there remains. Ang nag-iba lang dito is the shape of the load. Okay? So, there you go. Then, therefore, this one is a two-way system. Here also, so you have 10 feet smaller dimension divided by the larger. So, 15 feet. So this one is 10 divided by 15. That is 0.667. 0.667. So again, this one is greater than 0.5. So therefore, the shape of our load would look like this one. So it is a two-way system. Ayan. So, you also have to see, kunyari itong beam CD22. So, ito actually dalawa ang binubuhat. So, bakit dalawa? So, we have here this one, this side, and this side also. Ayan. So, yung ginamit kasi natin dito, 3 meters agad, which is also this one na siya, 3 meters. Yan. So, kung ganito, magiging times 2 din siya. Okay? Say, for example, here, you have the flat roof of the steel frame building shown in the photo is intended to support a total load of 2 kilonewton per meter over its surface. So, determine the roof load within the region ABC that is transmitted to beam BC. The dimensions are shown in the figure. So you also have to take note, determine the roof beam within the region of ABCD. So ito lang yung i-consider natin. So you have to neglect this part of the analysis. Kasi nga, again, within the region of ABCD. Pag ang kasama naman itong region na to, you just have to times it by 2. Okay, so let's check first if it is one way or two way. So we have here, so you have your short span divided by your long span. So you have your short span. What is your short span? It is 4 meters divided by the long span. So ang long span natin, 1.5 plus 1.5 plus 2, that would be 5 meters. So 4 divided by 5, you will get 0.8. So you compare it to 0.5. 0.8 is greater than 0.5. So therefore, it is a two-way system. So tama naman yung figure natin here. So again, yung long span natin has a trapezoidal load. Our short span has a triangular load. So we are getting the beam BC. So this beam. So ito yung kukunin natin. So what is the load here? So our load for beam BC is a trapezoidal load. Now, ano yung magiging W nito? So, sabi niya, The total load is 2 kilonewton per meter squared. So, ano ang i-multiply natin dito? So, you just have to multiply here in a length. Kasi times meter lang para maging kilonewton meter. Kasi again, this one is kilonewton per meter. So we will just multiply it to what? So again, this one is a three-dimensional load. So ang i-multiply lang natin is this distance. So you will have here 2 kilonewton per meter squared times 2 meters. So magka-cancel yung meter dyan. This would be 2 times 2, that is kilonewton per meter. So therefore, this load, so beam BC, it carries a trapezoidal load na 4 kilonewton per meter. Okay, another example. So you have here a steel frame is used to support a reinforced stone concrete slab that is used for an office. The slab is 200 millimeter thick. Sketch the loading that acts along beam BE and FEB. So we have here this one. So ang kukunin natin is yung beam BE and the load FED. So first, again, let's check if this one is one way or two way. So this one, A is equal to 2 meters and B is equal to 5 meters. So S divided by L. So our short span is 2 meters divided by our long span, this one is 5 meters. So 2 divided by 5, you will have here 0.4. So you have to compare it to 0.5. 0.4 is less than 0.5. So therefore, this one is one-way system. Okay, so again, if you have a one-way system, your load here would be a uniformly distributed. But then you have to compute it, or you have to multiply it by 2 because you have here also. So again, yung isa hindi natin minultiply by 2 because again, it is this one lang within the region A, B, C, D. Pero pag walang ganyan, say here, you have to multiply it by 2. Kasi you have this side and this side. So here, we have for your beam BE, then you have your beam FED. So yung beam BE natin, this one is 5 meters. Then yung FED natin, this one is FED. So this one is 4 meters. So we have, balikan natin yung figure natin ha. So we have this one, yung beam CD niya dito, uniformly distributed. Then yung BDF natin dito, or yung ACE, may concentrated load. So therefore here, concentrated load to. So you have your load here, have a load here. Then here sa BE, uniformly distributed lang siya. Okay, so how would we solve for that one? So sabi niya, it is just a stone concrete slab. So you have your unit weight of concrete. Again, this one is 24 kilonewton per meter cube and has a slab that is 200 millimeter thick. So again, this one is just a kilonewton. Okay, so you have to multiply an area. So ano yung magiging area natin here? So this would be 24 kilonewton per meter cube times our length here, which is 2 meters. So therefore, this one is 1 meter. Also here, so kasi dalawa siya. So therefore, this would be 2 meters kasi convert mo nga siya. Then, you have the thickness of the slab, which is, what is the thickness? 200 millimeter converted to meter. So, this is 0.2 meter. So, magka-cancel yung meter natin. So, therefore, this would be, you have 24 times 2 times 0.2. That would be 9.6. So our load here would be 9.6 kilonewton per meter. So 9.6 kilonewton per meter. How about here? So ano yung magiging load natin here? So this one is actually a column. So we just have to get this one. So, magiging volume na yung multiply natin sa 24. So, this one, you have your 24 kilonewton per meter cube. So, volume. So, ano yung magiging area natin? This would be 2.5. This is 1 meter. 1 meter. Then, our thickness, which is 0.2. So, there here, 2.5 meters times 1 meter times the 0.2 na thickness. So, therefore, this would be 24 times 2.5 times 1 times 0.2. So, that would be 12 kilonewton. So, 12 kilonewton. So, this one naman is symmetrical. So, same here and here. Kasi pag dito din, you have 2.5. Then, this one is also 1 meter. Then, your thickness is the same. So, therefore, this is 12.12. So, this is 12 kilonewton. Now, how about at the center? So, yung center natin dito, magiging times 2. Because this one is 2.51, then same thickness, 2.5 times 1, same thickness, tapos dalawa. So, times 2. So times 2. So, 12 times 2, you will get 24 kilonewton. So, and that's it. Okay?